All right. Um, then I've just put up. I've got to go through and clean this up a little bit. But basically, you're going to make a new method example class. You're gonna throw it in the scene. You're gonna write methods of the class using ufunction property. You're gonna write. So basically, I want you to make a blueprint callable class function and a blueprint pure class. No, I'm sorry. Let me get this. You're gonna write two methods. One method is blueprint callable, and the other one blueprint pure. Right. What these mean and basically, I want you to like throw this into go into the level blueprint, and show basically with the instance of the class that you can call these functions. And you don't really need. And again, what they do isn't that important. It's more that you can create these two classes. So let's just go back quickly. I don't need the header. Let's go to a. Yeah, here's a. Here we go. Hello light. So I've got basically this is basically the class where you basically run over the trigger and it opens up. Basically, I'm going to go in. I'm going to create a new function. And I'm just going to do test 1, and I'll make the other one test 2. And the big thing about this test number 2, I'm going to make it pure. And when I go, I'm going to compile. And when I go back to my event graph, I'm going to drag these in. So test 1, this is how this is what you would expect of a function that is blueprint callable. All right, it comes in this way, goes out that way. If anything, again, we can go in, we can add an output here. This is new prom 1, new prom 2. I'll compile. We'll go back to the event graph, and you can see here is a parameter in, parameter out. All right, so far so good. The other one, which is blueprint, is this one right here, and I actually need to go in and actually do an output on this one. Actually, I can do compile. As you can see, I've added, and this is I'm just doing booleans. I mean, this could have been. I'll do an integer. I'll make this an integer. And I'll go in and be like, hey, I can take this and we'll say, let's do the increment operator. And so now, I don't need this as a new param. There we go. Result. There we go. So I can compile, and there we go. So now I can take an integer, add 1 to it, and spit it out the other side. And if we go back to the event graph, it's basically, hey, what is the number going in? Here's the result coming out. And this is pure. Basically, it's not wired to the exec node. So I want you to create a new class where in the C++ side of things, we are going to create 2 new methods. And then those methods are tagged, one will be tagged blueprint callable, the other one will be blueprint pure. And then just basically drag an instance of the object into the scene. So here's hello light. So let me see. Here's one of the hello lights. So I'm going to go into the level. For our purposes, we're going to open up the level graph. I've got way too much going on here. We'll right click, we'll create a reference to hello light, and then we can call test 1, test 2. And this is, ideally, this is what you would end up doing. This is what I need to see. Ideally, you'd do something with it. But here is a reference to the class that you're going to create. And off of that, we're going to call these are public functions. And make sure that the functions, the methods are public, because we want to be able to call these outside of the class. So that's basically what we're looking at. That's the first part of this assignment. There's another part which is quick site to timers and events in Unreal Engine. And I also have the U functions in Unreal Engine, and update. I should update to, well, you can move it to 5. There's nothing's changed really from 5.2 to 5.4 in this regards. I'm just trying to see actor. Does it do any? Text render component countdown. I'm just looking at the okay. Yeah, no, it's not doing anything. Yeah, it's not doing anything that needs to deal with input. I just want to make sure. Yeah, it's not. Okay, good. Yeah, so I'm going to let you sit and read this. This is, again, the let you sit down and like play with the code. They've got extend override C++ with Blueprint. Again, what they want you to do is basically build upon the C++ class with Blueprint. And this is important, is that this is one of the first places where we're going in. I mean, we did this with the example, the variable example from the second lab. But basically, we're going in and out between Blueprint. The idea is that we should be able to go in and out between Blueprint and C++. Ideally, one of the things, I did back in the Blueprint example over here. Go back to Unreal. I basically added functions to a Blueprint class. Ideally, if you just wanted to do an add one like this on the pure one, go right ahead. Okay, let's compile. It's not going to worry about this, but all right. So I'm going to back off. I'm going to do the first example. And then go jump in and read the tutorial. And please read the tutorial first before jumping into doing it. Again, why am I asking this? So that you understand what you're trying to do before you start doing it. Right. Just reading that tutorial all the way through, you'll have a better understanding what's going on, what you need to do, and what you're going to do before you do it. So that's just basically, trying to help you comprehend, because again, part of this is what I'm asking you to do, particularly with that particular tutorial, is hey, you're going to go and read documentation, you're going to go and look at things, and I'm trying to get you in a habit of reading these things before you start jumping right into it and doing them, because this is a skill you're going to need in the industry over and over and over and over again. There'll be assignments where I'll be like, hey, here's a toy. Point and taken. That's literally your XR, your extended reality class. Here are toys. Have fun. Here are the tutorials that Epic or Unity is giving to you. Have fun. Go look what they're doing and have fun. And it's an important skill. Again, I probably have mentioned this a couple times, but I'm coming up on the 20th anniversary of my capstone project. And about this time, during that so 20 years ago, about this time, we were in early development of our project. And we were using the source engine. And I managed to find the map file that Valve had released publicly of the first map in Half-Life 2. So just to give you context, Half-Life 2 was released November 2004. So the game had just come out. Tools had just come out. The SDK had come out just recently. And we were actively working to build our capstone project. What's important about that first map is that it is one of 3 places in the entire game of Half-Life 2 where there is an actual cutscene. And this is the opening cutscene. I'm going to be clear. Half-Life, the three cutscenes are the intro, which is important here for my story. Later on, it's the outro of the game, and then when you meet, I'm blanking on her name, the female character. Wow, I'm blanking on the character name right now. But there are three points in that game where the camera is taking completely control away from you, and a cutscene is performed. That's a big deal with that particular game. That's how Half-Life. That's the mantra of that particular game. But they had released the first map, and that includes a montage cutscene showing, hey, the G-Man shows up and talks to you. And there's a montage of Half-Life 1 scenes, particularly the test chamber from the first game where everything goes wrong. That's shown in that. And they basically have a cutscene of the G-Man, of that test chamber. And basically, that's all in that first map, which includes that beginning of the train station. And the point here that I was able to go through the map and find the entities for the cinematic system that they had built. And then found those, had to do work to get them enabled in the editor, because they weren't in the editor out of the box, and that's a file there's a file for the editor for Hammer, and this is where entities are defined, and they weren't defined in the file that was given by Valve out of the box, so I had to go in and add those entities back in to that file, and then proceeded to produce examples, which I then passed around to my team. And we used all over the place. 2 of the people I worked with ended up over at Bethesda. So there we go. My weird connections here to there. But that process of digging into something and seeing how they did that, it's an important skill to build and have and to leverage, because you're going to need to do it. You know, Epic has built many examples. There's a whole example project that you can download that they keep updating. They've got map after map after map of different things. We will definitely probably jump into one of those at some point later on this term. But the first thing I want to do here is to start with a blueprint example. And if we go back to, it's under third person. There's the input, and they have the actions, fire, jump, look, move, and then under input they have default. I thought there was one more. Let me bring this back up. Did I enable? Oh, this is the third person. I'm thinking of the first person. One of the things that they've done in the first person, so we're going to look at third person right now. We'll take note of how they structured. But basically, here is the mappings they've set up. So in this case, I think we actually added the fire in the example here. There's a jump, a move, a look, and when we added a fire command. So pretty straightforward for what we're doing right now. I think later on, think maybe we use fire. I think we use fire to do the enable look at type functionality. Let's do what I do. Left mouse control button. Maybe not. But anyways, this is the idea, like, hey, there are actions and there are mappings. So let's jump back to the content draw, and then we'll go back to the blueprint, and then we'll go look at the third-person character. There we go. So the first thing that we want to look at is the add mapping. And this is important. This is one of the first things that we need to do, is that and begin play, they basically get the controller, the cast it to player controller, they get the enhanced local input system, check it's valid, and then they add the mapping. And we've done this over and over in Blueprint. I'm going to bring this a little bit closer. So this is the add mapping context. And then they now have events down here. Camera input, here's the look, here's the move, here's the jump. Do I actually, yeah. And these are all, I think these are, yeah, the target is character. I believe these are methods from the parent class character, so. Here's add movement input. Camera input, they broke the X and Y, and they basically, hey, add a yaw, and here's the add controller pitch input. So I want to, like, again, refresh us. What are we doing with Blueprint so that we can then take a look and understand what we're going to look at in the C++ side of things. All right, let me bring up. Actually, I can close this. Yeah, I'll save selected. Okay. All right. Let's now I'm going to jump into a project that is purely C++. Now, why am I going through this? I know this is not part of your assignment, but this is something that you will need to do. I want you to make sure that you are going through, that you have this understanding, because as we go further along, there will be moments where Epic is going to say, hey, we're going to set up this input this particular way. The documentation is not updated. It's using the older input system, the older bind system, and not the new input actions and mapping system. It's going to be your responsibility in those two tutorials to translate what Epic is saying over to that new system, because they haven't updated it yet. All right, what am I looking for? I think this is okay, first person template. All right. The one thing that we have to take into account is when you pick up the rifle, it adds a weapon component to the player, and it adds another mapping. So let's take a look. So we'll take a look. That will be evident in the C++ classes. So again, we've got multiple here.
We can't see you.
Oh, I'm on the wrong window. Thank you. Here we go. All right. Again, what I was trying to point out is that here's the weapon. It's a pickup. When this gets basically added, we'll look at the code itself. But basically, when this gets picked up, the weapon's added to the player. A new mapping is added to the player as well that has the firing. So if we go back to here's first person, and so here's the inputs. So again, we have here are the actions: jump, look, move, shoot. Default. Look at the mappings. Only has jump, move, and look. Whereas this is the weapon mapping. This gets added. The shoot is added when the weapons mapping added, which is okay. This is demonstrating the mapping system. This mapping is not added. Is only added when in the context of you having the weapon is brought to bear. So let's jump back. Touchscreen. We're not going to worry about that right now. Any blueprints? Yes. So one of the things that we are going to look at is that there are blueprint classes here still. So the first person blueprint class. So here's the character. Let's open the full blueprint editor. Let's go to the viewport. So this is. Let me look over here. The they've got the capsule going on, the arrow going on, the mesh, first person camera, and the first person mesh. These are all things added in the character movement. These were all added in C++. So we inherited from our the C++. Again, this is the name of this project is CPP development. So this is the C++ class, and we can actually click on it. Come on, Visual Studio is opening in the correct. What's going on? And we wait while Windows figures out what it's doing. Close to you. Turn on. So here is the C++ class for the character, and again, here's the .h. Again, here is the character inherits from a character. Again, config game here. So this is starting of where this is being built. I want stop yelling about everything. I need a little more room here. There you go. All right, so I want to look at the .cpp. So here is they're setting up all sorts of things, camera component. Wow. There we go. So again, here is begin play. So they have a function here called setup player input component. And Visual Studio is not working with me right now. So the first thing that they do is they actually get, man, come on. I'm gonna make this smaller. So they are getting a pointer to, they call it, the variable's name is called enhance input component. So enhance input component is the type. And they are casting player in component. So basically this is this is a function that's being, we're overriding this function. Come on. And so essentially what they're doing is essentially this is the first, hey, get the input. And what they're doing here is they're essentially mapping actions. So let me just check. Yep. So this is the code here. The code here is these enhanced inputs like bind actions. These are very much like the legacy in terms of how the original code would look like. Don't be. So again, they've got jump action, move action, look action. These are variables. So one of the things that's going on here is that here's the move action, here's the jump action. Should be a look action. Here we go. Here's the look action. So this is not, I don't know why they did this. I don't know why they're all together. But the idea here is that they have these actions, pointers to actions set in the code here. And this is where things get really interesting really quickly, is that back here, we go to, here's the blueprint version of it. This is the this version of the class that they actually, that the game mode is actually using. And the reason for that, let me go back and look at the code just quickly. Meta input, okay, categories inputs. So we go back and we go look at the input. They have a section here, jump action, move action, look action. And here they basically are assigning those actions here in the editor. And that's the big thing I want to get across to you is that, hey, there is when you what's going on is that basically they have these variables that are referencing actions, but they're actually assigned in the editor. And that's one of the big things here is like, hey, I'm going to create variables in my C++ class and then define them in the editor specifically. And a lot, you've done this a lot with Unity already. We've done this a little bit in Unreal to a certain extent. But this is a case where we create the variable in C++, and in the editor actually assign. So this is one of the key pieces, that these actually, what this jump action, move action, look action are actually, this is where they're actually assigned here in the editor. Jump back. Should be, again, here is part of the APON interface. So this is virtual void, override. So this is a function that has been provided to us to set up the player input component. Go back to the code. Cancel. Person mesh. This is studying up goes up. Just making sure. So if we dig into the code, we go back somewhere in begin play. This function is being called. In fact, we could probably go back and look at. Visual Studio. Acting weird today. All right, so let's look at the bind action function. Come on. So basically is bind action. Is it going to show it? No. All right, so it's what is the action? The next variable is an e-trigger event. So is it triggered? Is it start? Did it complete? And let's jump back to, let's go to the event graph just quickly. And I'm just going to do, so we're going to look at jump, and so here's triggered, start, ongoing, canceled, completed. These all refer back to, so basically there's an enum right here, e-trigger event. Start, completed, triggered. Start, completed, triggered. Here's ongoing, here's canceled. So basically it's has all these these nodes, exec nodes here based on that enum. So basically what you could do here, basically this is what that enum is for. It's basically which one of these pins are we dealing with. Here's the action value, but what we're looking at, so it started, basically is what class are we binding it to? This is always going to be this. If you're doing something with another class, then you're probably doing something weird. And then what method are we going to call? So in this case, we can see we're actually binding things back to, with jumping, it's binded back down to our parent class character. So there's jumping and not jumping. Move and look basically are bound here. So we'll look at, so basically so the ampersand class scope, class method name. And that basically what we're doing is these are basically function pointers that we're dealing with. We're using functions as variables. In C# we would call this delegates. Here in C++, they're function pointers. And so essentially, basically, this is what, so we're now saying when this is triggered, back up. So here's the move action, here's the look action. It's going to go in and call, so on the move action, it's going to call this function, and on the look, it's going to call this function. And they all take the F input action value, some sort of value. And I want you to, again, we go through like, hey, value, get the vector 2D, and then it's adding forward vector dot y, right vector dot x. Here's the look function. Basically, it is as long as the controller is not null pointer. Here's the add controller yaw input, look vectors dot y, add control pitch input, look x is vector dot, sorry, this is dot x, pitches dot y. And you can go back to the original blueprint class and see that this is, how this code maps to the blueprint class code. This is essential reading that you need to do. You need to take a look at this. Take a look at the bind actions. And we can actually go back. Actually, we will actually in this case now. going to let me. It's going to. And we go to definition. We'll actually jump to, here is character. This is the again, this is an engine class, so just be careful. We go through, there's a lot going on in here. Here's where they're setting up the arrow data. I mean, this is where, hey, go look at the code. I'm going to take a while. Get movement component. Again, here is setup player, the input component class. So let's jump over to Unreal for one moment. Let's jump back to our C++ classes. And here is, so there's two components here that are, the weapon consists of two. It's a pickup component and a weapon component. So let's go to the pickup component. Man. Oh, here it is, pickup component. So basically they have, so the big thing with this is that it's going to function on sphere begin overlap. So let's go look for that function over here. Other actor, on pickup, broadcast, notify the actor is being picked up, unlap, so it's no longer triggered. Let's go look at the weapon component. Again, here is the fire. Here's the attached weapon. And here they go, subsystem add mapping context, fire mapping context 1. So it overrides the, again, they've got a priority mapping 1, so it overrides the jump action. And then here's the fire, enhanced input. They're basically getting the enhanced input system again, and here they're binding the fire action. And again, let's go back to Unreal. Here is the weapon component. We go back to the blueprints. Here's the pickup rifle. Again, TP weapon, TP. So these are the components. Here's the weapon, and again, it should be under input. Again, here we go. Here's the weapons mapping, and here is the shoot component. So again, we've created variables in that function, in the class. We've created them in C++. They are defined in the editor with their actual variables. And this is one of those. Why are we doing it this way? So because we don't have to go use that. You don't have to go and grab the asset using that asset tool that you used previously for the static mesh. So. This idea that we build a C++ class, and the first thing we do is build a blueprint class on top of it to basically define the finish it, is going to be something that you need to get used to very quickly on a regular basis, because that's how Epic is building things. That's how they've built these templates for us. Now we'll look at more other code later on, but this is where this is our starting point. Again, this week we don't have we don't have to deal with input this week with the tutorial, but the idea here is that as we go forward, you will be. This is going to be an important piece. There will be a quiz issued next week on the input system, the enhanced input system in C++, and when you write it in C++, and then the blueprint class as well. So you've got a week to sit down, read, look at the code, ask questions. I'm blanking right now where exactly is the default mapping being mapped, and I'll find that at some point. And when I do, I'll make an announcement saying, hey, this is the line of code I was looking for. I've been a talking head for maybe too long, so the questions about what's going on. Yep.
So all that C++ code you just showed us
Yep.
is not something we could just do in a regular blueprint.
You could do in a regular blueprint.
And then
I mean, like basically that bind action, like you were getting an event, and then so they have a way where when you build a action, it has an event that you can then bring into your blueprint class. That's the red node, and it has the different completed, started, triggered, all of those.
yeah, I also saw like it added on like a capsule collider.
Yeah, that's in that's in the character class.
Mm-hmm.
So that's something. Go look at what the character class is actually adding. Again, it's the character class is a specialization of the pawn to do human-like things.
I just figured it'd be a little easier just to do it on the editor instead of like typing in like the
Not
actual
necessarily.
values
There's time and places for having C++ classes. There's a time and place for C++ classes. Like in the original Unreal Tournament Community Edition, which is on UE4, UE5, they basically say if you're building a weapon, you should be building that in a C++ class. That there should be a C++ class for that weapon.
Mm-hmm.
The goal is that we then take that weapon and then we then move forward, and we finish it in the blueprint class.
So should every blueprint have a C++ class that's the base of it, right? Or
Not every blueprint class. No. Your core application classes. So right now we're looking at our pawn, our default
okay,
default pawn. We're looking at our these. For our purposes, we're trying to understand what's going on the C++ side, because there's a time and place where you're going to have to write C++ code.
mm-hmm.
Blueprint can't do everything. Blueprint can do a lot, and we can extend Blueprint, but there's a time and place where the C++ code is what you want and not the Blueprint code.
And how
There's times where you really want a C++ class that has a function to call, as opposed to writing that in Blueprint.
And how would you differentiate like which one to use?
Well, it depends. It's based on function.
Okay.
Yeah, it's per purpose and function.
You just run across it and then
It's one of those you can start, like, again, as designers, you can start in a blueprint class and then move things out of blueprint it back down into C++. I need to sort this array in a particular way.
Okay.
Easier to do in C++ than it will be in Blueprint. Yeah, there's a time and place where the C++ code is going to be what the code you want. There's probably speed, and C++ code is by out of the gate is going to be faster than Blueprint. Now, don't get me wrong, Blueprint has caught up and it's done well, but there's a time and place where the C++ code is what you need. Another example where this will come up. There will be a time and place where you will be working with a third-party module or another module that is in C++.
Okay.
You need to access that through the C++ code
And then you
to
can extend
grab it. Yeah, and then extend that class into Blueprint. Again, the goal of this class is to make you comfortable writing both C++ and Blueprint code and them working interchangeably with each other.
Can we take a Blueprint code and then just, would there be like a button and it just compiles back to C++ code, or is that all, you have to manually do all that?
If you no, yes and no. The yes part is that somewhere there is a translation. The Blueprint class is being translated into code, but that's the engine doing that side. What I'm saying, the no side of it is that if you made a function in a Blueprint class and you want to bring that down to the C++ it's inheriting from, you'd have to manually write that class into the C++ side. So that's the no side of it. Is that if you wanted to move it down, you'd have to do the work to refactor from the Blueprint class down to the C++ class.
It's a lot of work.
It is. I know there's a lot. I know I know the C++ side of Unreal is a bit of a slog. But again, this is an engine that was built in the 90s. There's a technical debt that you guys have to deal with in terms of how this engine is set up, how it's structured, and how it performs. And again, we look at the bind. I mean, here's on pickup. If we go back, I mean, here they've set up on pickup here's the pickup. Here's an event on pickup, and it's setting up. Here's the attached weapon. Tells the first-person animation blueprint has the rifle, which is built into this is something that's built into the character. But for our purposes, I'm trying to think. Go back to here's that enhance input action. I could write blueprint in some blueprint. I could also have this built right into my character out of the gate. Again, the C++ class is the first inheritance from character. Whereas in the Blueprint class we were building everything in Blueprint. Here is the enhanced input action jump. Here is started. Here is I think either cancel or completed. And we go back to our code. Go back to the character right here. Here is the jump action. E-trigger event started. E-triggers completed. So we saw those exec notes off that event. Here they are. Literally, this is the code for that exec node. This is the code. Jump action started. Jump action completed. What does it bind to?
Can a Blueprint class how do I say it? can it listen to like events from like a C++ class?
Yeah.
And then they all just kind of work
Yeah.
intertwined, right?
Yeah, they do. I mean, like, again, these are actions that are being bound in the C++ side.
Mm-hmm.
But that, we'll talk about, so one of the things that we'll talk about a little bit later on is, we call something here in fact, I believe, the tutorial is showing you that you can create an event. I gotta be careful. One of the things that we'll be doing is we'll create events on the C++ side, and then we'll have a place where they're called in the blueprint.
Just like the custom event thing, right?
Yeah, it's a custom event. We'll make the custom event here. We'll define it in C++, and then in the editor, in the blueprint class that inherits from it, we'll have an event that basically, when that event is evoked, this node gets called.
Mm-hmm.
So that's how C++. Again, we're starting right now on, hey, Blueprint can call C++ stuff that we make.
Mm-hmm.
The next step later on is, hey, C++ can evoke things that Blueprint can pick up. Again, this is that I keep going in and out like, I forget the name of the two snakes around the medical symbol. They come in and out like a DNA helix.
Yeah,
It comes in and out, in and out, in and out. That's what we're looking at in terms of C++ and Blueprint. That's how. Again, don't get me wrong. C++ is a slog and it's a pain in the behind at times, but it has its purpose. And this class is setting you up to understand, to use C++ in conjunction with Blueprint, as you would do it in the field.
Mm-hmm.
And again, right now, our first thing right now is basically we can set up the input in the C++ side. And here's how we would do that. So we know how to do that so that there's not a question about that. When we see the old input system, we can be like, oh, it wants to set up this type of event. Oh, it wants to set up this type of event. And all we have to do is just translate what they're trying to do there into the new system. And I'm feeding you this. This is, again, there'll be a quiz next week on this, so that I'll like, hey, what is this line of code doing? Hey, what is eTrigger? And we can let's take a look at eTrigger event. Let's go to definition. It's a enum. And it's bit flags, whatnot. But here we go. Triggered, started, ongoing, canceled, completed. As we see in the event in Blueprint. Again, there's a lot more with the enum stuff here. Blueprintable type, bit flags,
Can you give an example of how Blueprint would communicate with the C++ class again? I know you gave the example.
Yeah, but that's let's go. You're doing that this week. So again, you're creating methods. They're going to be written in C++, and then you'll be able to call them. You'll make an inherited version of that in the Blueprint class. And then from there, you'd be able to call those. Those are functions you are now available to you to call to do your work.
I got you.
Let's go through and let's do that in an example. Okay, so I need to bring the dot H. So here is okay. Here's the development character .h. They have a public a get mesh one player one, and get first person camera component. Let's actually write something. Sorry, I want lowercase int 32. We called it test2 int 32 value. So I'm just going to go back here just to show you the documentation. So here is blueprint callable, category attributes, meta, display name is alive. But basically what we want, let's just grab this. I want to copy that. That's an image, isn't it? Oh, why are you doing that? Here we go, ufunction. And I'm just going to go back. So I'm going to give it a U function. And I'm just going to make sure. I'm going to use both just to be on the safe side. It might yell at me because I'm using both of these, but I need to go to go back. Here we go. Come on. You attach it to the class here. And return value. Actually, I don't have to put it in parentheses. I'm going to add a CPP on the end of this. Save. Save. And then we can compile. Compiling our code. So we've compiled it. So here's the BP first person character, and it basically inherits from this class. We can now go in here, and this is the test to CPP. So again, just showed you like literally, and this is blueprint again pure, like we did with in the blueprint example. Now here is the C++ version. So for Blueprint to interact with C++, it's basically we're dealing with, it's either going to, right now it's going to be functions, events, which are specific type of, which is a specific type of a function. So we'll eventually, the next step is, so right now we're just dealing, hey, here are functions. The next step is we'll create events, and they have their own structure to them that we'll want to deal with. Why again, part of what we're doing here is setting you up. Again, this class, again, sets you up so you can use both C++ and Blueprint interchangeably, but this is also setting you up with the foundation pieces where you can really dig in and use replication to your advantage. Now, we'll start with the Blueprint side with replication, but really, like, why was Unreal Tournament, the Community Edition, saying? Because your weapons need to be replicated. The best code for replication is written in C++.
So now pretty much all the character moving class, I think.
All of anything that inherits from the CPP development character. So that was that's the character class that was created part of the template. We've now added to that core class that new function. Now we did this two ways. We did this, now this is the C++ version of the project. In the Blueprint version that I had up earlier, we created this function, but we did it in Blueprint.
Mm-hmm.
Now we've done it here in C++. And that's the goal here, is that, hey, I'm trying to get you to, like, this is the first way you would interact with your C++ code, is you'd make functions that are Blueprint callable or Blueprint pure. And that's the start. This is the first entrance way coming from where Blueprint can interact with C++. There'll be a point where we'll be able to, where Blueprint can then, again, is interacting with C++. C++ can then interact with Blueprint.
Back and forth, right?
Back and forth. And this is the first step. And I know this is kind of baby steps, like with the example. And this is why, again, I did this in the C++ development in the character class.
Mm-hmm.
So there's a lot going on in there. Again, the goal is, again, I want you to, particularly for the input system, look at how it's set up, how it's what's going on.
And how did you say the Blueprint class communicates again? It was through events, right? The custom events.
There will be events that will set up there'll be events later on that will set up in C++.
Mm-hmm.
That Blueprint that C++ can call and then generate. Because the idea is that we call this event, this is essentially we invoke the event.
But wouldn't that
And then in Blueprint, we'll set up a node for that event, and when C++ calls that event, that node gets triggered, and it does what we need to do.
Could it be the opposite way for Blueprint to C++?
Yeah, just function. The opposite way. So right now, the opposite way, when Blueprint wants to do something with C++,
Mm-hmm.
we're calling a function. We're creating a function for it that can be called in Blueprint.
Okay.
So we're going the opposite. So we're starting with, hey, Blueprint can call some C++ code.
Mm-hmm.
We're starting with that. If we can do that, then we can deal with the next step. It's like, hey, C++ is going to have an event, and that event gets evoked, and in the blueprint class, because we have the node set up again, like right here, like here, this is an event. But like we'll have a red block somewhere that we've created, but that's a future lab. That's a future lecture.
Okay.
Yeah. Right now we need to go one way before we start going the other way. And again, this class is slow and deliberate because the C+ side is a pan behind to work with. So it's baby steps. Like again, this week it's knowing the input system that Epic knew, the enhanced input system, knowing the U function, blueprint callable, blueprint peer, and then there's a tutorial where they're gonna do things. They're gonna do variables and counters and whatnot, which would be useful. And they're doing a lot of things in C++. That's the other thing. So it's showing you what are the pieces in C++ that they're doing. They're doing the majority of the code in C++. I know I've been dealing with your questions. Other questions? Yep.
Pure. Well, can you explain pure?
Okay, so in Blueprint, when we create a function, let me create a normal function. This was test1 BP. We go back to the event graph and we bring in test1 BP. This is a Blueprint function. It has a node, an exec node here to start it, and the exec node out here when it's done. So far so good?
Yep.
Okay. I'm going to make test to BP. I'm going to go back to the event graph. I'm going to bring this out, and right now it is set up this way. I need to compile. There we go. Oh, there we go. So when we look at the graph, there's an option here to make it pure. Let me go back to the event graph. When I turn on pure, it basically collapses it down. Now let's go back to it just one more time, and we'll go to inputs. Value, and this is going to be an integer, and then an output. This is going to be the return value. We'll just jump in, and this is again, we go in, integer. What is it doing? What are you doing? There we go. Epic just had a brain fart and thought I was doing a float for some reason. But basically, this is the again same function I did in the other project. But here is test2b. Basically, it is taking a value, adding 1 to it, returning it. So here's the blueprint. So here is, I'm going to make this a little bit bigger. Here's the blueprint version of it. Go back. Here is the C++ version of it.
So you're just making a note.
Yep, I'm just I'm making a note. So the other thing that I've done, let's go back to Visual Studios one more time. Come on. Stop being a pain. The other thing is I've said this function, this method is blueprint callable, and I've tagged it as blueprint pure. And by doing that, and I can actually go and let's just do. Let me just grab you just quickly. take off here. Callable. And I'm just going to make this a void function. So back over here. Void. This is test 1. There we go. So here is the test 1 CPT version of that function. So I'm going to save that. Please do something more significant than just, empty classes, empty functions. But I'm going to save. I've saved both of those files now. We'll go back to here. I'll compile because I'm now adding that new function, that new method, I should say. So let's jump back to here. Let's go back to so I've made it the test BP, test 1. Here's the event graph. So here is the 2 pure versions. Now I can go test. That's 1 CPP. Equivalent code for all intents and purposes. So you know how to build functions here, because I banged that over your head over multiple times. Now showing you, hey, you can create nodes of functions in C++. That's what this week is all about. It's like banging the head. Hey, remember how I banged in the heads about functions over here in Blueprint? You're inheriting your C++ class you're inheriting from. You can have those nodes show up as well from functions you create.
By using Callable.
Yep.
Callable
By tagging the method as Blueprint Callable, that ufunction macro, we can now use it in Blueprint. The other mantra that I want you to think about is that, hey, you are writing pieces of code, things, components, whatnot, that are going to be used by other people, specifically artists and designers. Hi, I'm a designer. I can tell you how bad we are because I know how bad we are. All right. You need to set up things for your artists and designers that are easy to use, that are easy for them to, conversely, also easy for them to understand. If there's something in your code that you don't want them touching, give them an interface. This is something that we're talking about in Game and Simulation 2, by the way. Why do you write an interface? Because you don't trust the person down the hall with your code to do as they see fit. You give an interface so that they can use your code effectively, and that you get things from them that you would expect. For example, if you had a structure that held a date, month 13 means nothing to you. Month -65 means nothing to you. God forbid they put day as G. Like I said, you will meet people and you know that they are a moron. This is why we write interfaces for them. And then you have to deal with your artists and designers. Now, artists are more reasonable, but designers, we think we know what we're doing. let me say, as a designer myself, I say designers know what they're doing. We will find things in your code. We will find things in code that are bugs and think that's how it's supposed to work and turn it into a feature on you. Once upon a time in Minecraft, you could put a ladder and skip a block and then put another ladder. That was considered a bug by Notch, and he fixed it. And there was much gnawing of teeth after he did that, because he broke many worlds by making that fix. But that was a bug. That was an undesired feature, and it was fixed. Let's talk about another undesired feature: bunny hopping. So the issue with bunny hopping is that when you jump, you're running at the fastest speed and then propelling yourself faster. And by taking lots of little jumps, hence bunny hopping, you were picking up speed. Fixed in Counter-Strike, fixed in multiplayer, not fixed in Half-Life 2 single player for some reason. And if you go look at any speedrunner who's worth their salt, they don't deal with the buggy whatsoever, because the buggy's too slow for them. Because
that buggy is not slow.
That buggy is not slow. But they ignore the buggy completely and just go off on a bunny hop run. It's hilarious. Yeah, don't get me wrong. Like speedruns of Half-Life 2, about 45 minutes to an hour, tops. It's like watching a film when you watch a speedrunner and play Half-Life 2.
Didn't they beat Half-Life 1 in like 20 minutes or so?
I think you can, but Half-Life 1 is a different beast.
Yeah.
It's a different beast. Less controlled narrative beats and spaces in that game as would be Half-Life 2. There are places where the player is trapped in a room and has to wait for those narrative beats. Good speed runs, that player is jumping all over the place and doing stupid shit because they can. Because they're just literally waiting for that. It's not a cutscene. It's a animated sequence to finish. Again, I want to be clear. It's not a cutscene per se. It's an animated sequence, and the reason is because you still have full control of the camera, your player, and the character, whatsoever. This includes later in the game, you are trapped in a little container, but you still have control over where you can look. So it's not a full cutscene. It's one of those when we don't have cutscenes where we're taking control of the camera. How do we lock the player in a room and deal with it?
That reminds me, so, quick fun fact, I think in the Crusher room in Half-Life 1, those are actually tramways. You can stop them.
What was that?
The crushers on the Crusher room, when they throw you in the Crusher, the ACC unit?
It's been so long since I played Half-Life 1, so yeah.
It's in one of the scenes you can just stop the Crusher from crushing you entirely.
But that's Half-Life 1. There are things that are being done in Half-Life 1 that are not being done in Half-Life 2 for various reasons. So I'm gonna keep us from going too far back. Don't get me wrong. The light code from Quake. So we need to understand that the current version of the Source engine, Source 2, is inherited from Source. Source is inherited from Gold, what they would refer to as Gold Source. That's Half-Life 1. Half-Life 1 is it's either Quake 1 or Quake 2 code. I forget which one. I think it's Quake 1. Might be Quake 2. But the light code for a flickering light in Quake 1 is still in Half-Life. It's still in Half-Life 2. It's still in Source 2. It's still in Half-Life Alyx. And there's an article about where they've actually gone back and gone through each of the games and generated a GIF for each of those games that show the flicker, and it's the same flicker all the way back from Quake. So What's not broken, don't fix what's not broken.
Wait,
Alright.
sir, can I make a quick announcement?
No, not yet.
Okay.
It's still recording. So, any other questions about today's lecture? Going once. All right, I'm going to stop the recording here.